No, I spilled my pants. Shoot. We're gonna know how to eat.
Alright, we all have this paper open. Ready to go. Notability, document, or paper, your choice. No guided notes today. Quick PowerPoint. So we're in section 9.4, and we're continuing kind of our idea of logarithms. And if you see the word common log, any ideas or any guesses what base we're talking about? 10, right? That's the most common, that's why it's called common log. So, you will see in the textbook and on my tests and quizzes that instead of writing it as log base 10 of some number x, I'm going to shorten it, and I'm going to take out the base 10 entirely. So it's just going to become log of x. Why don't we write the base 10? Well, it's not really necessary. It's used so commonly that it's a waste of ink, it's a waste of time. Kind of like if I were to say x to the first power, do you really need the first? Don't we all know that x to the first is the same thing as x? So you'll notice the textbook will not have a base. If you don't see a base, it's base 10. So you will need a calculator for this, and the reason why this is on the calculator portion is because we all have that log button, which means base 10. So this would be on the calculator part of the test. That's the base part. And we're all on a level playing field because we all have calculators that do base 10.
So for this one would be a calculator?
Yes, yeah. For the take-home portion, you can use a calculator. For the in-class portion, which is after spring break, no calculator. This part would be on the calculator portion. Yep. Yes, sir. Not a video. You good? Okay. Alright, so let's go ahead and find log 3, log 0.2, and log negative 6. Yeah.
Did you say the in-class test was after spring break?
After spring break.
Okay.
Yep. Alright, what do we got? So, remember, we're rounding to 4 places after the decimal. So we're typing in log of 3, log of 0.2, log of negative 6, just to kind of get an idea. You all have that log button, right? We found that the other day. Not ln, that refers to natural log, that's something different. We'll get to that. What do we got for 3? Who has an approximation? Notice my squiggly equal sign. What does that mean? Well, it's an approximation. It's not exact. What kind of numbers are we coming up with? Say what?
0.477, 1, 2.
If you had to round to 4 decimals, what would you say? 0.477, what do we got? 1, right? Alright, what about 0.2? What do we come up with? So you should all be trying this on the calculator. Log of 0.2. Okay.
Negative 0.6989.
89. And some of you are saying, hey, you can't have negatives. Well, your answer can be negative, you just can't take the log of a negative. So we're good to go. And then what about log of negative 6?
Can't do it.
What does your calculator say to you? It spits it out. It says can't do it. Why not? Well, what it's asking is this. 10, remember this loop method we talked about? 10 raised to what power is going to give you negative 6? Nothing. You can't do it. 10 raised to any power, no matter if it's a positive or negative, will always give you a positive number. So we might write DNE, which stands for does not exist. Or you could just put a circle with slash through it, right, meaning there is nothing. Logically, do these make sense? You're saying, well, yeah, my calculator said so. Well, but what if your calculator is wrong? And you're saying, no, calculators are never wrong. Well, they might be. If you type it in wrong, it might be incorrect. We'll double check the loop. Does 10 to the 0.47 power give you 3? Well, what if it was 10 to the 0? What would that give you? 1. 10 to the first gives you 10. So 10 to the 0.4-ish, which is between 0 and 1, should give you a number between 1 and 10, does it?
It'll be 4.
Or should it?
Dang it.
Yeah. So do you have to double check them? No. But if you're curious as to does the calculator button really work? Well, yeah. Because if you look at the pattern, 0.4 is between 0 and 1. 3 is between 1 and 10, so it seems logical. Alright, let's go ahead and solve an exponential equation using logs. But there's something ironic about this slide. Look at the title and look at the equations that I'm asking you to solve. It says solve using what? Logs. Do you see any logs besides the word log on this page? No, but it says we're supposed to use logs. So what's up with that? How are you supposed to solve that with logs if there are none?
Put in log.
Put in logs, right? And you say put in log form, which would look like what? Log base, let's reverse the loop. What do we get? 3 of 11 equals x. Okay, does that help us? Does your calculator do base 3? Some of them do, but most of them, no. So did putting it in log form really help us? No, but it has a log, which is good. Instead of log form, here's my suggestion.
Make your own.
Can we just add a log to each side?
Anna.
And you're saying, that doesn't seem logical, how can you just do that? Well, think about a balanced equation. If you add it to one side, you have to add it to the other. Technically, have we maintained the balance? Yeah. Does it seem weird to just add a log to each side? Kind of. But let's see why this is going to help you. We're trying to figure out what x is, right? Well, right now, x is in the exponent spot. Do we ever solve for things that are in the exponent spot? No. So how do we get rid of it? How do we get it out of the exponent spot? Think about the 3 properties we talked about this week. I heard it. The power property, which says we can do what? Take it out of the exponent spot and put it back in front. So this really becomes x log 3 equals log 11. Does that get us closer to solving for x? If you're solving for x, you want to get x by itself. Is it by itself?
No.
Almost. What do we need to get rid of? The log 3. So right now it's being multiplied by log 3. So to get rid of it, we do the opposite operation, would be divide. Some of you say that seems weird to divide by a log. Well, log 3 is just a number. So really all you've done is divided each side by a number. So these cancel and you're left with x. Log 11 over log 3. You say, we can't do that. Why are you asking us? Well, what did we just practice doing on our calculators? What are the bases of these?
10.
10. Do you know how to do base 10 on your calculator?
Yeah.
Yeah, so would you type in log 11 divided by log 3 on your calculator and see what you get? And round to the 4th place after the decimal.
Let's.
Do you have a number, Amy, for us?
Yeah,
What do we got?
I think it's wrong though. 1.362.
Okay, there's one option. Any others? Nick?
I didn't
Oh.
actually solve it yet.
Oh, okay. Who plugged in log 11 divided by log 3? Yeah, Lizzie.
2.1826.
So the question is, it can't be both. There's only one answer. How do we decide which one works? Well, which one seems logical? 3 to the what power gives you 11? Well, 3 to the first-ish. 3 to the first is 3. 3 to the second is
I'll see.
9.
Is not.
If it's 3 to the 1.3 power, that's going to give you a number that's less than 9. Are we looking for a number less than 9? Not so much. So this seems more logical, and this is actually the correct answer. So how did we get this?
I warned you
Why are
guys.
they?
I warned you.
Here is the key. It all depends on how you type it into your calculator. The calculator is not always right. Here's how I think some of us typed it in. When you click log, right, that's what it gives you. And what a lot of people did was said, okay, I'm going to type in 11, and then I'm going to take divided by, and then log of 3.
Oh, I get it.
Do you see why that is wrong, or why that's not actually doing what you want it to
Finish
do?
the parentheses.
What it's doing is it's taking log 3, taking 11 divided by that, and then taking the log of the whole thing. Do you really want it to do that? Instead, you want to take log of 11 and divide it by log of 3. The key is parentheses. You've got to finish out the parentheses. So Amy, if you try that again,
I
you
got the
get the
right
right answer.
answer.
Okay.
Yeah.
Be really careful. Calculators are fantastic things, but if you don't use them right, they will lead you astray. So check that.